Off this video with a little bit of revision. So here's a line, and it's the line with the equation minus 2x plus y minus 10 is equal to 0. And I just want to revise how we would find where this line cuts the x-axis and where it cuts the y-axis. Okay, so just to revise over here, something that you should be aware of already. To find out where it cuts the x-axis, what you actually do is you let y equal 0. So if I was to let y equal 0, it would be minus 2x minus 10 is equal to 0. Minus 2x is equal to 10, so x is equal to minus 5. So where it cuts the x-axis then will be the point minus 5, 0. And then to find where it cuts the y-axis, you would just let x equal 0 and do the same thing. So now we're moving on to a circle. So what we want to do is we want to find where this circle cuts the x and y axis. Okay, so the first thing I want you to do, please, is write down what the equation of this circle would be. And I want you to write it down in the form x minus h to be squared plus y minus k to be squared is equal to r squared. Okay, so just pause the video now, and I want you to write down what the equation of that circle would be. Okay, so as we've seen in the last videos, the equation of this circle would be x plus 3 squared plus y minus 2 squared is equal to the radius, which is the square root of 13 squared. And then just to simplify that, that would be x plus 3 squared plus y minus 2 squared, and if we square square root, we're just going to get 13. Okay, so now we want to find out where this circle cuts the x-axis and cuts the y-axis. But you do the exact same thing that you would do if this was a line. So to find where this circle here cuts the x-axis, so to find where it cuts the x-axis, all you actually have to do is let y equal to 0. So if I was to let y equal to 0 in my equation, I would have x plus 3 squared plus, if y was 0, this would just turn into minus 2 squared, and that would equal 13. If I multiply this out, I'm going to get x squared plus 6x plus 9. This will become plus 4, and that will equal 13. And now I have x squared plus 6x. If we look here, 9 and 4 is going to add to give me 13. This is 13, so if I bring this over, it'll go. So that is just equal to 0. This is a kind of a quadratic, right? We can do common factorization here. I can take x out. I'm left with x plus 6 is equal to 0. So then my two answers are x is equal to 0, x plus 6 is equal to 0, and x is equal to minus 6. So this touches the x-axis in two places. X is equal to 0 and x is equal to minus 6. And that actually makes sense if you think about it, because if you have a circle and if you had the x-axis coming along here, it does make sense that the circle would touch the x-axis twice. Okay, to find where the circle would touch the y-axis, you do the exact same thing. So to find out where it would touch the y-axis, you would just let x equal 0, and the question would look very similar. Okay, so here is a circle now in this format here. So what I want you to do now, please, is I want you to find where this circle cuts the y-axis. So I want you to find where this circle here cuts the y-axis. So you're obviously going to let x equal 0. Again, if you want to revise anything about a circle equation in this format, it is the previous video. Okay, so I want you to pause this video now, and I want you to find where this circle here cuts the y-axis by letting x equal 0. Okay, so if we were to do this one, where we let x equal 0, that will go and that will go. So we're just going to get y squared minus 4y minus 21 is equal to 0. This is a quadratic, so I'm going to solve this y and y. I need two numbers that will multiply to 21 but will add or take away to give me minus 4. So that is going to be 7 and 3. That's going to have to be a minus, and that's going to have to be a plus. So my two answers are y is equal to 7 and y is equal to minus 3. So these are the two places where this circle here cuts the y-axis. And just to be correct about it, that would technically be the coordinate 0, 7, and this would technically be the coordinate 0, minus 3. Okay, so I'm going to try and get you to do this question here, please. Right? So here we have a circle, and they say show that that circle there does not cut the y-axis. Okay, so I'm just going to get you to pause the video and to try that on your own. Okay, so to do this one, to show that this circle does not cut the y-axis, what I'm going to do is I'm going to follow the same procedure anyway and try and find where it cuts the x-axis. Okay, so to find where a circle cuts the x-axis, we now know at this stage that we just need to let y is equal to 0. So if I let y equal to 0 up here, I'm going to get x minus 7 squared plus minus 10 squared is equal to 25. So that y there will just turn to 0. Multiplying this out, we're going to get x squared minus 14x plus 49. This is going to become plus 100, and that is equal to 25. We see here we're just about to get a quadratic, so that will be x squared minus 14x. 49 plus 100, take away 25, that's going to give me plus 124 is equal to 0. Now we have a quadratic. What we would usually do is try and solve it. You're looking for two numbers that will multiply to give you 124 but will add or take away to give you 14. You're not going to be able to do that. So that, because you can't do that, it means that there are no answers, and this circle does not cut the x-axis. Okay, but I'm just going to do a little bit of revision here. Here we have a quadratic. Now, do you remember in 5th year we did a thing called the discriminant, which is the square root of b squared minus 4ac. So if I fill this in here for this quadratic, I'm going to get the square root of b squared, which is minus 14 squared, minus 4 times 1, and c is 124. Okay, and then finally then I'm going to get an answer of 196 minus all that will become 496. So the final answer there is the square root of minus 300. So, and we can't get the square root of a negative number, all right? You're going to go into complex numbers or imaginary numbers. So there are no answers to that there. So that means then that this here does not have any solutions, so it means that the circle does not cut the x-axis.